Now we're going to look at a couple of text problems. We had a problem of a graph like this. It looks something like maybe a parabola. Doesn't necessarily have to be a parabola. And we have four values of x specified: 1, 3, 5, and 6. And we're going to look at things associated with the points that correspond to those x values. So the x equals 1 point, the x equals 3 point, which really should be over this way a little further, the x equals 5, and the x equals 6 point. Now, one question we're asked is to order the following quantities. The derivative at 1, that is f prime of 1. The derivative at 3, f prime of 3. So which one's greater, f prime of 1 or f prime of 3? Look at the graph and see if you can tell me. F prime of 5 or f prime of 6? Okay? Can we see which one's greatest and which one's least? And then we also want to compare those with the average derivative between 1 and 3. I'm sorry, the average slope between x equals 1 and 3, and the average slope between x equals 5 and x equals 6. So we have these 6 quantities to put in order from least to greatest. Well, if we observe the way the function goes, we see that the derivative is decreasing. The derivative always is less at a subsequent point. The derivative is positive because we're steeper here, and less steep, and less till the derivative reaches 0, and then it becomes negative. We have greater and greater negative numbers, larger and larger negative numbers, but of course we're talking about greater than and less than, which means further along the number line or less far, so the negatives are certainly less than the positives. So we have strictly decreasing values of the derivative across this function, so that the derivative at this point is greater than the derivative at this point, is greater than this, is greater than this. If we order the derivatives from least to greatest, it'll be this one, this one, this one, and this one. Now we also want to put the average values, or the average slopes, into this scheme. So where do the average slopes lie? Well, let's think about it. The least derivative is here, the next least is here. The average derivative between here and here, since the derivative is always decreasing, is certainly going to be less than it is here and greater than it is here. So with a decreasing derivative, the average has to be less than the value at any point. The average for any interval after a point has to be less than the average at that point, and the average in the interval before a point has to be greater than any derivative before that. So that the average derivative here will lie between these two derivatives. Similarly, the average derivative here will lie between this and this. After this point, the derivative is always less than it is at this point, so the average over this whole interval has to be less than it is here. The average derivative for any interval before this point has to be greater than the derivative at this point, and of course the average over this interval will therefore be greater than the derivative at this point. So the order is derivative at this point is less than the average derivative, is less than the derivative at this point, which is less than the derivative at this point, which is less than the derivative at the average derivative or the average slope here, which is less than the slope or derivative at this point.